Hi everyone. So today we're going to continue using the Pythagorean theorem. We're going to take a look at some level 2 questions, which are just word problems. Okay, so let's just review really quick what the Pythagorean theorem is. It is a formula used to find a missing side of a right triangle if we know what the other two sides are. Doesn't matter which ones we know, we can substitute into our formula and solve from there. A squared plus b squared equals c squared, or leg squared plus leg squared equals hypotenuse. Doesn't matter which leg goes first. Addition is commutative, so we're allowed to interchange that. Okay, example 1. If you place a 5-foot ladder against the top of a 4-foot building, how many feet will the bottom of the ladder be from the bottom of the building? So we have a pretty small building, 4 foot, and a pretty small ladder, 5 foot. Maybe we're dealing with like a kid's playhouse or something. But before I start the question, I'm going to highlight some important information, just like you would if you were annotating notes in English class. So it's important to know that our ladder is 5 feet, and our building is 4 feet tall. And then the goal is to find out what is the distance from the bottom of the building to the bottom of the ladder. Okay, so it's important that we know what we're looking for. We want to know what the question is asking of us and how to set this up. So we have this word problem, but we don't have a picture, which makes it really hard to try to figure this out. So our first step here is going to be to draw a diagram and label it. So first, I'm going to draw this little building. I'm actually going to do it in a different color so we can see it. Give me 1 second. Okay, so here's our building. And then our ladder is leaning against this building. Right, so here's my ladder. And here's my building. So the building is 4 feet tall, and the ladder is 5 feet tall. And then we want to know what is the distance of the bottom of the ladder to the bottom of the building. Now, it's totally safe to assume that the building is, a regular building. It's 90 degrees from the floor. So it's safe to assume that that's a 90-degree angle. Okay, I'm going to label this X because we don't know what that is. Okay, so hopefully this diagram, it's not, the best drawn diagram there is, but you get the idea that we have a ladder leaning against a wall, and it creates that 90-degree angle, and it creates a right triangle. So now let's label our triangle. So remember, the hypotenuse is always right across from the right angle, so this is our C value, this is our hypotenuse, and then we're going to label the 4A and the XV. Remember, it doesn't matter which one's which. On the legs, we can interchange. Okay, from there, we're going to use the Pythagorean theorem to solve for that missing side. So I'm going to write my Pythagorean theorem at the top. A squared plus b squared equals c squared. And I'm going to just substitute what we know into our formula. So we know what a is. A is 4, so I'm going to write 4 squared. I don't know what b is, so I'm going to just, I'm going to write x for b. So we don't know what that is. And then we know that c is equal to 5. So instead of writing c, I'm going to write 5 squared. From there, we're going to square. 4 squared is 16. So I get 16 plus x squared is equal to 5 squared, which is 25. And then we're going to solve the equation. We're going to subtract 16 on both sides. So remember, we want to get the x by itself. This cancels out. We're left with x squared is equal to 25 minus 16 is 9. Now remember, to get that x by itself, to get rid of the squared, we're going to find the square root of both sides, because then the square root and the square cancel out. So we're left with x equals the square root of 9, which is 3. So the base of the ladder is 3 feet from the base of the building. Hopefully you notice we have 3, 4, 5 for the sides of this right triangle, which is a Pythagorean triple. So if you have the side, if you know these two sides, technically you don't really even need to do the work because you know, okay, these are two sides of a Pythagorean triple. I know the other side has to be 3. So that's a good way to look at it too. All right, let's take a look at one more example. So you start driving north for 27 miles, turn right, and drive east for another 36 miles. At the end of driving, what is your straight line distance from your starting point? So here we're talking about north and east. So I'm going to draw a little compass. So never eat sour watermelons. I don't know if you guys learned that in elementary school, but that's how I always remember it. So now we're going to draw the diagram. I'm going to just highlight some important information. We drove north for 27 miles, turned right, and we drove east for another 36. So what is the distance from your starting point? Okay, let's go back to drawing this diagram. All right, so say we're starting here. We drove north for 27 miles. For some reason it likes to do that to me. Okay. Let's try that one more time. So we drove north for 27 miles, because north is up, right? And then we turned right and went east for another 36 miles. And it wants to know what the distance of our starting point to our ending point is. So this is where we started, this is where we ended. It wants to know that distance. And we can safely assume that this is a right angle because we went from north to east. So we're going to assume that these streets create that 90-degree angle. So we have our diagram. It's drawn. It's labeled. I'm going to just call this X. You can call it C if you want to. It doesn't really matter as long as it's a variable because we don't know what it is. And we're going to use our Pythagorean theorem to find that missing side. As you can see, I rewrite it over and over again just so it's there for reference and I know what to plug in. I need to know what my A, B, and C's are. So let's draw that arrow. So we know that X is our C value. It's our hypotenuse. 27 is A. 36 is B. Doesn't matter which one's A or B. Matters which one's C, though. Remember, keep that in mind. I know I keep saying it. So A squared, so that's 27 squared, plus B squared, 36 squared, is equal to C squared. We don't know what C is, so I'm going to write X squared. Like I said, you can leave it as C if you want to. It doesn't really matter. So now we're going to square 27. That gives us 729 plus 36 squared, which is 1,296, equals X squared. That's a 2. Let me just erase that. Just 2. Okay. We're going to combine these, and that gives us 2,025. And that's what X squared is equal to, or C squared if you use C. We want to get the X by itself, so we got to find the square root of both sides of this equation. Square root and the square cancel, so we're left with X over here. And then 2,025 is a perfect square. The square root of that is 45. So I believe for this Delta Math assignment, you are going to be dealing with whole numbers. So that means that this distance from our starting point to our ending point is 45 miles, right? So identify the important parts of your word problem, draw the diagram. Do not try to do this in your head. It can get really confusing because you might not know which one's A or B. So try your best to draw a diagram and then use that Pythagorean theorem to find your missing side.